You know how you can walk past something every day and barely even notice it? Well, what if I told you that a single, kind of confusing photograph actually held the key to building an entire digital city? Let's dive in and see how they pulled it off.
Okay, so this is where it all begins. It's a famously complicated traffic sign from Davis Square in Somerville, Massachusetts. I mean, look at it. At first glance, it's just a total mess, right? You got 5 streets all smashing together in one spot. But for a team of researchers, this picture wasn't a headache, it was basically an instruction manual. So the big question is, how do you get from that real-world mess to a super high-tech solution? Well, you build what's called its digital twin. Just think of it like creating a virtual lab, a place where you can mess around with traffic, pedestrians, all the city rules, and not cause a single real-world traffic jam. Pretty cool. And that's really the heart of it. Researchers literally fed this one photo into a system, and it automatically cooked up this incredibly sophisticated computer model. Every single line, every street name, every little symbol on that sign became a hard and fast rule in this brand new virtual world.
The fancy name for this is a reproducibility simulator, but what does that really mean? Well, its whole purpose is to create a kind of digital playground that's built on real-world data. It lets us study exactly what's going on, test out huge changes, like what if we added a new road here, and see what would happen, all from the safety of a computer screen.
Okay, but building a whole digital world, it isn't magic, right? It takes some serious logic. The simulator had to figure out what it knew for a fact, the stuff it got directly from the sign, and what it had to assume just to make the whole thing feel real.
And this slide just lays it out perfectly. Over on the left, you've got the hard facts. We're talking 5 key data points that were pulled straight from that image. These are the non-negotiables, the absolute rules of the road. But, to make it actually feel like a real place, the model needed some educated guesses. So on the right, you see the 18 assumed parameters. Things like traffic flow, pedestrian speed, driver behavior, all the little details that bring the simulation to life. So let's start with those hard facts. First up, the absolute basics. The sign confirms there are 5 different streets or arms coming into this intersection: Elm, Day, Dover, Holland, and Highland. Simple enough. Next, see those do not enter symbols? Those tell the model something crucial. Day Street and Highland Avenue are one-way exits. You can go out, but you can't come in. And just by process of elimination, that means the other 3, Elm, Dover, and Holland, have to be two-way streets. And just like that, with only those simple rules, the basic skeleton of our digital intersection is built. It's ready to go. Okay, now this is where the real magic happens. Because with a working model, we can finally start asking, what if? We can run all kinds of experiments and check out different scenarios that would be totally impossible or just crazy expensive to test out in the real world.
So the researchers set up 5 key experiments. First, they simulated a normal, everyday baseline scenario. Then they cranked it up for the stressful morning peak hour. They also asked a really bold question. What if we just got rid of those one-way restrictions altogether? Then they threw in a high pedestrian pressure day. Think like a farmer's market or a festival. And finally, they tested what would happen if they added new signs, like stop signs, to try and reduce conflicts.
All right, so they ran all these different simulations. What did they actually find out? Well, the data gives us the answers to 3 really basic but super important questions that any traffic engineer would want to know. Question number 1, where is everybody actually going? This heat map tells that story. It shows the most popular routes, and it's pretty simple. The darker the red, the more traffic there is. Just look at Holland Street over on the left. Those dark red squares show a ton of cars coming in from there and heading straight for Day Street and Elm Street. For city planners, this is like gold. It's a perfect snapshot of how traffic is flowing.
Okay, next up, how safe is this intersection? This chart here tracks what they call conflict events, which is just a nice way of saying near misses. Now check out those really tall green bars on the far right. Remember that scenario where they got rid of the one-way streets? Well, the number of near misses just explodes. It's proof positive that a seemingly simple fix could actually make this intersection way, way more dangerous.
And the final big question, the one we all care about, how long am I going to be stuck in traffic? This plot shows the average delay for drivers. Focus on those red dots. That's the morning rush hour. As you get more and more cars pouring into the intersection, that's moving from left to right on the chart, the delay doesn't just climb, it skyrockets. This literally pinpoints the exact breaking point where the whole system just grinds to a halt.
But look,
This is about so much more than just one single intersection in Massachusetts. This kind of technology has absolutely huge implications for how we design and manage, well, all of our cities.
So, who really benefits from something like this? Well, urban planners. For one, they can test out a brand new roundabout design without pouring a single drop of concrete. Researchers and students get this incredible lab for studying complex city dynamics. And here's a really big one. Developers of autonomous vehicles, self-driving cars, can use these digital twins to train their AI on the world's absolute trickiest intersections, running the simulation millions and millions of times until the car gets it right. You know, the source material really nails it, calling this a rigorous, reproducible synthetic laboratory. And that's the key right there. It's a way to apply real scientific precision to the messy, super complicated problems we face in urban life. It turns a single confusing sign into a source of genuine clarity.
And that really brings us to the final thought here. This whole thing started with just one photo of one intersection. But just imagine applying this kind of thinking everywhere. Think about it. What's that one super frustrating, confusing, or maybe even dangerous spot in your own city that you just wish somebody could fix? What part of your world deserves its very own digital twin?